recorded loud. Okay. Can you view the chat box, or do I need to do that? You can. Okay, perfect. Thank you. The new folks that are joining us, you'll get to learn. You'll get to know Anne very well. She moves the information along. We call her the information specialist. And if you look at the data room and all that organizational and the visual side of it, she did that. And we're very proud of that data room, and we think it moves information pretty articulately. Of course, at least we need more contributors to that, but we'll get there. All right, contributors of information. Okay, so I'd like to introduce two folks. First being as Dr. Brad Hyatt, and if you wouldn't mind, maybe turn on your camera. Dr. Brad Hyatt is the Associate Dean for the University of California, Fresno. He is a great colleague. We've been collaborating for almost about 1.5 years now. We met each other at a conference, and I think, and we do several conferences throughout the country the last couple of years, and it's typically in the subject matter of estimating, but kind of expanding the boundaries of estimating into the business side, and it's more systemically thinking from the beginning of business case to the end, which is relevant to this study, of course. But Brad, if you could, I'll introduce you first. If you could just maybe just talk very briefly about your dissertation, and then also and just maybe introduce yourself just a little bit, and then I'll introduce Vishesh.
Great. Thank you, Paul. So again, my name is Brad Hyatt, and my dissertation is focused on the quote-unquote analytics maturity of organizations. In other words, how an organization can go from using data analytics or AI at a very basic level to utilizing those tools at an advanced level. And when I started my dissertation about 5 years ago, within the construction industry as a whole, nobody was really talking about AI specifically, but even more than that, very, very few organizations were talking about or thinking about data analytics as a whole. Many companies were doing it at a very basic level, but no one was doing it at a very advanced level. There were some companies that were starting to delve into that arena, hiring data analysts and data scientists. And so by the end of the time of my dissertation, a few years later, there were a few companies that were a little more mature, a little further along. And then over the past 2 years, obviously, that has escalated quite steadily. And now almost every company is talking about AI specifically, but some form of data analytics, and then some are pretty far along. So just the evolution in the past 5 years has been pretty exciting. And then where I fit in with this is obviously when we talk about lunar construction, and we've mentioned this before numerous times, but we just can't do things the way that we've always done them here terrestrially. And AI is going to be a big part of creating tools and processes that will allow us to do things in an efficient manner, in a manner that we can actually achieve the goals in a way that allows everyone to move forward together. So,
right. Yeah, that's awesome. And then you also estimated for the Department of Navy quite a bit, wasn't it?
Well, yes, yeah. So my background is I'm not I didn't start out in academia. I actually started out as a civil engineer in the Navy, working for Naval Facilities Engineering Command for a number of years. Also with Navy Seabees, supporting the Marine Corps as they were doing various operations. Then I worked as a consultant for a couple of years as a project manager, owner's representative. And then after that, transitioned into academia. So I've been here at Fresno State for about almost 15 years.
Wow, that's great. That's awesome. All right, and we'll probably start with your presentation first, and then I'd like to, before we go into that, I'd like to introduce, if you can turn on your camera, Vishesh. I'd like to introduce Vishesh Singh, Dr. Vishesh Singh. Received his PhD just recently. Jazz hands, right? And on his in his expertise, and again, we've been collaborating for, I don't know, probably 8 years now or so, and we do quite a lot of conferences together. It's forward thinking, out of the box thinking as far as estimating, analysis, and again, full cycle estimating has been kind of the our work, and which is kind of the methodology we're teaching here at UC Davis in the estimating analysis a group of students. Vishesh, do you are you?
Yeah.
You okay? There it
Can
is.
you
I
see me?
have it on gallery. Yep, I can now.
Right.
So why don't you introduce and probably the same format that Brad did, and then we have to get into the actual presentation.
Yeah. Hi everyone. This is Vishesh. So I guess talking about my background is typical civil engineer, who got like really interested in improvements, problem solving, and then I delved into the world of lean construction. Then after that into machine learning, and then I'm basically now kind of merging those two through part philosophy and part tools and methods to solve these problems. I mean, what's amazing working with Paul is that obviously he's like grounded in the actual industry experience, but his uh, thoughts are not limited to how he like sees the problem or how he sees the system. And there's a lot of parallels that I found in the kind of the estimating philosophy that we are working on here with other kinds of work I've done over the past 5-6 years during my PhD. And that work was basically around data-driven production planning and control. So similar issues exist in the actual production on site when you're planning it and controlling it, which is mostly considered on the scheduling side, but there's a lot of cost implications about how you build something and then how you schedule it. My research has been basically applying those philosophy principles and then also using machine learning and latest like data-driven methods to analyze the production as it happens on site in real time, then feedback into a control system, and using that data and collecting that data in such a way that then you can use it in future projects to predict the production, given certain characteristics of the project process and locations.
Yeah, and oh, I'm sorry, I didn't mean to interrupt. Go ahead.
So basically, I mean, like as Paul was saying earlier, like estimators, their work kind of expands beyond that. Like they can go into the financials of the company, but also their work can move downstream into the actual construction and like how the building is going to be built to the level of production. And so I bring that aspect of how do you connect the production data to your estimate, because at the end, like that's a major part of your cost.
Yeah, that's great. It's great. And one thing you'll notice is that when you hear Brad and Vishesh give their theories and practical theories and what have you on their work, is we're thinking not in terms of we're not necessarily thinking in terms of somebody goes out with a with a what do you call it? We don't even have them anymore. A clipboard, right? Do they even use clipboards anymore? I don't know. But go out there and when you look at it, say, yeah, okay, and you get a verification. We're speaking in terms of technology that can move very fast. And again, just reminding when you hear these thoughts, part of the paper is if this is a system, and let's say this is not to scale, let's say this is a prefabricated mechanical system pod, and the things that are encapsulated in this that makes it has intelligence to it, even though it's a nerd intelligence. But just through coding and things, it gives it a sense um, of intelligence, but it's not active intelligence. But just kind of keep that in mind as far as the perception that wherever it is, the prediction, the very beginning is never lost from the very beginning to the very end. And that all stakeholders that need to know everything about this are informed almost in real time. And then prediction models are constantly moving to repredict, and then root cause analysis on that prediction is fed back in. So there's a lot of moving parts to this, but the point is to realize reality to realize reality downstream to the best of our ability. And remember that what we're trying to achieve here as a team, everybody on the call, and there's about 30, 40 people on this team in the industry, aerospace and academia and practicing, is we want absolute minimum variance to the predicted state. Think about that. Absolute minimum variance to predictive state, which means as close to zero variability of prediction as we can get to. And that's a tall task, and it's quite complex. So just something to remember as we kind of move through. So who wants to go first? Brad, would you like to go first, or?
Sure. Yeah, I can go
Okay.
first.
And do we need? Okay, you got it. Okay, perfect. Thank you.
Great. So my sections, and I would say that Vishesh also is part of these sections as well. So there's overlap between what the two of us worked on. But really what I tried to focus on is kind of the underlying ideas or concepts and some theories that are related to AI within construction. This first part really just talks about AI's role in the full life cycle. And there's various ideas and concepts that are built in this that I think are very applicable. So at the very beginning of this section, we talk a little bit about generative AI. So that's, things like ChatGPT, also large language models, models that create content from underlying data. And really where this applies, the way that I envision this applying within lunar construction is that we're going to have all this information available. It's going to be collected and stored, and to be able to augment those individuals that are involved in lunar construction to be able to help them make decisions faster. So a very simple example of that would be if we have someone that's involved in construction of the moon, perhaps doing moving materials from one place to another. They have some questions about what the payload is, and they're going to be able to have access to a lot of different data. As Paul mentioned, we're going to one of the most important aspects is to collect as much data as possible, but to be able to sift through that data is going to be really challenging. So where generative AI, a chat bot would be helpful is for that person to be able to ask questions to a system and be able to get that feedback immediately, but to do it in an accurate way. One of the issues with large language models and chat bots at this point is the reliability of those answers. So one of the key aspects that we would have to think about with lunar construction is to be able to create models that are reliable based on the underlying data that's available to us. So, and that's kind of what this section talks about. There's a nice graphic in here that Vishesh kind of pulled together about, where AI is within these domains of computer science, domain knowledge, math and statistics, data science, and AI is really kind of at the crux of all of that. So that's really that first page or the first sections. And then the next portion really goes into AI applications. And I kind of broke it down into kind of different examples. So the first one there and the second full paragraph under AI application section, material and equipment. And just really, talking about estimating cost, the expense of those is something that is first and foremost. The other thing that we envision with lunar construction, and this group has talked about before, is that most of it is going to be based on equipment. So I think in one of the first meetings we had, I can't remember who it was, but brought up this idea that lunar construction is going to be more akin to heavy civil construction or even mining for that matter. And so it's going to be very equipment intensive. And so, being able to track those costs real time, understand those, that's going to be the largest portion of the cost involved in the project, along with the materials and getting the materials there. So this kind of talks about some of the aspects that would and needs that would be involved in that. Labor and tooling, this is going to be a kind of a smaller aspect. One of the things that within construction as a whole, specifically commercial construction, residential construction, we still kind of see most of it is labor intensive. We don't envision that'll be as much in lunar construction. However, there will be some things that labor and smaller tools will be involved with, and so being able to predict those more closely, handle those, because that's where we see a lot of variability across specifically construction projects. So Patrick, thank you for joining us today. And then logistics and transportation. This is another aspect, obviously, getting things from Earth to the moon. That's going to be a huge cost. And so allowing AI to be a part of that to help to optimize all of those aspects will be really important. And then the last portion, just got cost tracking and analytics maturity. So again, my dissertation is about that analytical maturity. So one of the things that I think is going to be really important is to make sure that the partners involved have a really good understanding and are quote unquote mature in their understanding of AI and analytics as a whole, so that they can utilize these tools as efficiently as possible. And again, with what I've seen in the past 5 or 6 years is that there are a number of construction companies, and for that owners or different construction organizations that are becoming more mature. They're understanding how to apply these tools, and specifically AI, to increase the efficiency within their organizations. And that's going to be really important to partner with those companies, but it's also going to be important to bring along other companies that aren't as mature but want to be a part of this. They may have skill sets that are necessary that align closely with success of lunar construction, but they may not be as mature using AI and analytics. And it's going to be important to bring those along and have a system in place to where those organizations can get up to speed as quickly as possible. So that kind of is what I discussed in that section. And then on the right-hand side there, risk and trend analysis, kind of moving away from more basic generative AI and moving to more machine learning tools, more predictive tools. And so one of the ways that I always explain this is that AI can do a lot of things, data analytics, machine learning can do a lot of things depending on what you want. It can be as basic as just giving you information, is the way that I described earlier, and it can go all the way to predicting an outcome and even prescripting an outcome. So we can develop machine learning models that will prescribe and say, these are decisions that you should make based on the data that's underlying there. So, and tying back into what Paul talked about with this predictive state and that zero variance, we want to get as closely to that. So having these machine learning models and then having the data that is underlying those models is really important, so that we can have good predictive states and then control the risk as much as possible. So that really kind of sums up what I included here in the paper. Obviously we're still in a very early stage and theoretical stage, but I think this kind of provides the basis for what we want to focus on as we move forward.
Sure, that's outstanding. And these papers, I think originally we sent out one that had it combined, and we still had the tracker on, and it was a little difficult to get through it. And so we separated these out just so to focus on us reviewing it. And these will be placed in the data room as separate papers, I think, because we still have to stitch how these will interact. And again, I'll do the majority of the stitching as far as that's concerned. But what I'd like to do is just kind of pause just for a little bit and see if there's any questions right now for Brad. I'll just take a quick pause. Any questions? I know that's a lot coming and we'll have to kind of review it, but on the surface, anything that comes to mind? Okay.
Yeah, that was really interesting. I guess one question off the bat is this all hypothetical, or are there some practical applications right now?
Yeah, there are practical applications now. So as I mentioned, there are more and more construction companies that are using various tools. We actually here at Fresno State, I have a couple of colleagues that are working with both startup companies that are using AI within construction and some construction organizations for the implementations that they're using. So there's lots of good examples. We're still fairly early on within the construction industry, so I would say that we're in the phase where there are a lot of tools available, and we're starting to sift through the tools that are going to be the most prevalent. But again, as I alluded to, and we talked about when we first started to meet, I think identifying the tools that are used specifically in heavy civil construction, heavy construction that's very equipment intensive. I think those are the areas that we'll be able to bring in and identify what works there and what could potentially work in a lunar setting. So those are the tools that we would focus on.
Yeah, and I think adding to that as well is I think we're a construction industry, and the analytics of construction it's the right time to solve this problem that we have.
Yes.
It's the right time. And the reason is we're not locked right now. The industry is exploring, and we're trying to leverage this new technology, and we're in a renaissance, I think, much like we were when we were learning how to leverage the BIM model, right? So it's an exciting time, and it's almost like the right time to solve this type of problem. We wait too long, then all these technologies are locked and they're too rigid to apply to this problem.
Yeah, there's a lot of adjacent research right now into text to model based engineering, using large language models to create the criteria that can be fed into like AI aided CAD programs to create optimized components. An additional work to take that step back, and you can look through the different layers where eventually you can just start with the straight requirements. And there's we're doing other research right now using AIs to help build up model-based systems engineering for the requirements generation. And it's very easy to see where you can just start with kind of just the simplest prompt, and then have the AI ripple the entire way through and end up developing a fully optimized model at the end. Some of the models I've seen, the cost portion is fairly simplistic. Once we start to get more and more sophisticated, that cost portion of it is going to be even more important. Or I shouldn't say even being more important, but it's going to be an important factor in any design.
Yeah, I think I'm that's a great comment, and I think when we say cost, what we're also thinking is when we say cost, we also know that what the team has kind of established and thought is that once we hit launch, and that our cost model, it almost moves beyond at that point the superficial, or I don't want to say that the objective costing of a widget, because it's insured and commodities are law contracts. Checks are cut, and if there's a loss of payload, then the insurance company comes in and has a calculation that they use to say, you're going to be there's going to be a replacement in monetary value for that piece or that widget. But then when we move beyond that, the cost is money, and cost is duration, how long it's being used, and what is the purpose of the mission, and how long is it? Is it a 60-year-old building or launch pad, or is it a 3-year, or whatever that is? Those are factors, and it's a paradigm shift of how estimating needs to think beyond the basics. The widget costs X. It's much more complex than that.
Yeah, and just to build that all into an optimization model I've heard of some companies doing that for their products. I have not seen it automated yet at NASA, but I can see that becoming huge in the very near future as the tools get more and more automated.
Yeah, that's great. And I got to remind you, Steve, remember you have a brilliant scientist, Dr. Ferrar, Dr. Figueroa. And he's done some amazing work. As a matter of fact, that's in our priority reading, because we think that G2 that NASA is using could potentially be a vehicle that harnesses AI development tools with generative design tools, and all of our stuff into one system that is the master brain, if you will, that ties it all together. And anyways. So we've kind of identified that. We'd sure like to have more communication with them, because we think it's really very relevant to the work we're doing, because without a centralized way of collecting this data and distributing the data like a neuronet, that's where the challenge will be. How do we get all these different systems to talk together? How do we get all of these tools to talk? How do we get all the analysis to talk? And what does it mean? That's some place we have to definitely explore. So,
okay.
Vishesh, tag your ed and.
Sorry, can you actually stop the share? I'll share something else.
Sure.
Yeah, I mean, this discussion, I didn't join in the questions, but I think it's very relevant to what I'll talk about, and also I'll try to answer those questions in the presentation too.
And that was the share. You stopped to share there, Brad. Okay, good. Yeah, perfect. Thank you. And good job, Brad. By the way, that was fascinating. Thank you.
You see it in the presentation mode? Or?
Yes, we do. It looks very like I want to buy the tickets to that movie you got there on
Yeah, it's spoiler alert, it's not made by me. So I just gave the white paper text and the images to one of the generative AI websites, and this slide deck is produced by that.
Really?
Within like a minute.
That's funny.
So yeah, I mean, everyone knows the topic. So I guess the part of the overall challenge is the traditional methods are inadequate for the complexity of this project, unless we want to be highly over budget and over time. So the solution that we were talking about earlier is has to be a more innovative estimation philosophy, because its tools and AI won't solve the problems. But then AI does accelerate that adoption of the philosophy, because there is a lot of overlap and synergy. And then the topic I want to talk about is what is the framework we are trying to implement, both at the philosophy level and the tooling level. And that is highly based on what I call it as standardized baseline data architecture, and the full cycle estimating unit tracking system, the short form that you see there. So this is kind of the taken from the paper itself, but the kind of the overview of from start to the end of the project. You want to track the design and cost, and what allows you to do that tracking is a standardized baseline data architecture. I'm not going deeper in this image, but I'll explain what that architecture would include. This I just added at the end to Steve's question of how is it being implemented, or is it theoretical? So the data architecture as well as the framework is based on this work, which is my PhD dissertation. So in this case, rather than estimating the cost, it's estimating the duration of any production activity. So the bottom part is that framework, and then there's a production control part, which has data collection, data analysis, and then production control part. And then once that data is collected, you again store it, analyze it, and then in this case, we use work density as a construct to predict future production. This is kind of one of the examples of how it's been implemented in the real world already.
Yes, and I just want to go back to that last slide because I want to give plug to UC Berkeley and their outreach to the industry, and just explain that very quickly because I know you're very much a part of that. Just give them a quick plug real quick because they're very relevant to the industry and how the progression is moving in the industry.
Yeah, so on the top you'll see P2SL. That's the lab, Project Production Systems Lab, where I used to work with Professor I.S. Tomline. She leads the lab, and then our research is mostly industry facing challenges. So the theoretical parts, but all of them are usually worked through what we call as action research. So working with actual projects on site.
Okay, thank you. Appreciate it.
Yeah, thank you. So again, like coming back to the data, so I see it as 3 levels, the building blocks of that estimation process. One being the core data itself. So it can be material, labor, equipment, and then the production methods, all the things that are objective data that actually affect the cost. And then the elemental approach is kind of the how you divide the project into various segments and elements, which can be along different dimensions. And then the classification system, which can be a huge work breakdown structure or any kind of uniformat, master format kind of similar system that classifies as per systems or as per materials or different ways. Obviously classification system and element approach can be different for different types of projects, but the core data should remain unified. And that's what the focus here is. So the standardized baseline data architecture that I was showing before basically constitutes of these, the full cycle estimating unit tracking system and project contextual data. Within the full cycle cost, what we divided into subjective and objective, where objective is, as like Steve was talking before, about this model generation, and then from the model you can cost elements. That is, if you are costing something that's already in the model, that's objective, or something that's confirmed and paid for, that's subjective. But there are parts that are variations in the system or that are dependent on characteristics of means and methods. Those kind of things are subjective, as you're not completely sure how it will be in when it becomes reality. So tracking the objective and subjective over time, that's a huge difference from the traditional methods. And then attaching to that is certain project contextual data, which tells about the project, the processes involved, the location, the product being built, the means and methods used, and about cost and time related to those elements. So as Brad showed this image before, the like AI being this intersection of various fields. Within that, the domain knowledge would help us to understand what are these contextual data that we need to include in our model, because there's obviously like statistical methods to identify these contextual information, but even to begin, which are the potential contextual features of your project process location, that has to come from the domain knowledge from the experts that understand what actually affects the cost of a project and affects the production of any system. So once that is identified, then you can apply this AI system for various applications, such as causal analysis to basically identify what's the causation between different features for the project outcome, in this case, the cost. And then the pattern recognition. So in this case, you can do pattern recognition for prediction, but also for time-based analysis, where you're trying to identify what kind of patterns arise when different decisions are made. And then trend analysis, which is during the life cycle, you want to track your trends, and basically controlling your cost as design matures. I think at the end part, which is the actual production when it happens, that contextual information can then be connected to the tracking of the production itself. So we propose various ways where you can get this information as the production happens. So basically, the project management has a lot of different sources of data, either manually inputted or through automated workflows. Then we are assuming that we will have access to some kind of reality capture, either through vision systems or X-ray vision and different vision-based captures. This is also what I used during my PhD. So using a computer vision-based production tracking system to identify what work is put in place already and how much of it. And then if we are using big equipments or small tools, all of them can be smarter in the sense they can give you the production data directly as they do the work rather than you measuring it as the work is complete. And this is kind of the workflow that project contextual data being attached to the production tracking and to the estimate. And then once the production is, as the production is tracked, you feed it back to your estimating data so that those two match. And then you have this historical data for given different project contextual data and production, what was the impact on the cost. I think from this analysis, you can basically have data from your previous projects and data from your performance tracking. And both of them can then be used to identify either are you having cost overruns as per your past projects, or will you have some delays that can impact the cost? Sorry about that. And then from those predictions, you can have risk analysis and risk mitigation. So identifying strategies to overcome these overruns, and then also trend identifications to know where the cost is trending so that you can make corrective measures. Let's skip this. And then I wanted to add this is not in the white paper, but recently I've been working more towards applying large language models and multimodal large language model. And I mean, we do see there's a lot of data needed to apply these systems. And there's like different complexities or customization of how much you want to customize your large language models for the application. We'll probably begin at the bottom left where we can do simple prompt engineering, zero-shot learning to make these models useful. But I think as we improve the system by having more data and more customization, we can increase the prompt part to zero shot to a few shot, and then embedding your historical data so that you can use the historical part, and then hopefully in future having your own custom models that can also improve through reinforcement learning and human feedback.
Yeah, just let me interject something real quick, and this is to you, Vishesh, Dr. Vishesh. Stein. Can you add a little verbiage in here? Because I think it's an important point, and I appreciate you putting the slide up. It is very important because we have to think about not only nothing's current state, but the beginning framework, but also we have to think about how we communicate that and the infrastructure needed in place for growth and this type of expansion of process and analysis. So if we could maybe just put a little verbiage in there, that'd be great in your section. Thank you.
So I mean, the slide was like not like fully baked in the sense of it is a lot of information for especially if you read it first time. The main idea here is like if you start from lower end, you can use existing infrastructure that services like OpenAI or Anthropic provide, that you don't need to customize anything or build an infrastructure. You basically have these, basically API calls that gives you answers based on your own data. So the earlier, like simpler adoptions are not exactly changing the infrastructure, but giving some examples of your own data so that it can fine tune to your use case. But as we move forward, we would want to, with the subject matter expertise, you need to understand like what are the different scenarios that can exist when you are using these models, and then understanding those scenarios and making it part of the model itself would be the crucial part. So all these prompt tuning, fine tuning, even prompt engineering, you need to understand what are the different scenarios, how these models can respond to your whatever prompt you're giving, and then how that would affect the actual like construction or the estimation process, and being able to understand different scenarios and accommodate into the model so that it performs as you expect it to perform. So
yeah, I think again, just getting back, I think this is too big of a subject. I know you can go deeper into it, but I'd like to see maybe 2 paragraphs, right? That just gives the elevator speech, of it. And then like as we use the terminology of off ramps, of expertise, this would definitely be an off ramp. But I think it's important enough to at least have mention in there.
Yeah. I mean, I was not originally including this, but from the conversation that Steve had earlier, I think this is kind of the path of applying these.
Yeah, good job for thinking out of the box and putting this on your presentation today. Thank you.
Yeah. And then, I mean, to conclude, basically, we need these advanced methods for the unique challenges. And part of it is the standardized architecture for how the data is collected, analyzed, stored, and then used. And yeah, there's a lot of improvements in the AI models that we are getting. So I think the race that we need to catch is not which model or what kind of AI to use, but getting us prepared for the right data so that whenever the data is ready, we are able to use it with the whatever state-of-the-art AI system exists. I think that's it from my side.
One comment is that the astronaut was lifted there because there's no the AI didn't put footprints. So but anyway, sorry.
Maybe it's no footprint.
Yeah. Anyway, so that was you guys really did a great job on your presentations. Let's take a little pause. And are there any general questions? Again, the detail, this was a session just so when you read it, you understand the premise. And I think the task of the group is, now that you've seen, again, this is being recorded, but now that you've seen the presentation and the meaning behind it, when you read the paper, then is their perception when you read it is and hearing them give their presentation, when you read the paper and from your lens as the verbiage is as you're taking in the verbiage, does it create questions that you want to ask, or is it parallel from your understanding what was presented to the paper? And again, what's in the writer's mind is typically it's very difficult to shave off, as we all know, to shave off all the knowledge we have in our minds to really condense it down. And so sometimes when we write these papers, as we all know, because we've all written our authored papers, that we sometimes can lose, we use what's in our head and on the paper, and we may be missing something very important that we have to convey. So maybe that type of a correlation. Before I'm looking at the time to be sensitive to time, before we move on to adjourning, is there any specific questions for Dr. Vishesh Singh? I would like to thank both of you. Oh, go ahead, Steve. Sorry, I didn't mean to interrupt you.
Oh, no, I was just going to say thank you. Another fascinating presentation.
Yeah, thank you. I thought it was fascinating also. These papers again have been separated, much easier to read. It won't mix the ideas together. Thank you. Good luck on your midterm. Thank you. It's the new folks that just came in. He has a midterm he's running to right now because he wanted to be here to the end. He's literally running there. He has microeconomics, so wish him well. He's brilliant. He'll do very well, I'm sure. Okay, Steve, I'm going to mirror or amplify what you said. These were fascinating presentations, and I really appreciate both of you sharing your thoughts. And as we put the paper together, are there any questions before they adjourn? Are there any questions about reviewing the paper? We'll give you probably more detail when we get it as far as on the final paper. How do we review it? How do we peer review it? And a specific sheet that maybe you would fill out, or it's probably a smart sheet or something like that. That's more collaborative. But for the preliminary review and questions, is there any thoughts as far as direction or questions that the team has at this point? Or is it as clear as mud, as they say?
I suppose I have a question, and that is, what level of technological development are we looking for? Are we like AI is still very rapidly evolving? There is the capability the AI has today, and then there is the capability that we think AI might have in 6 months, a year, and 2 years. So I guess the question for guidance is, what level of technology are we assuming will be available to implement this process? Are we going to be conservative and based on technology we know is going to be that we know is available, that we know we can do, or are we going to project and say we're going to hang our hats that we can do, you know, X and Y in the future, even though we can't do it now?
Yeah, I'm going to start, and Brad and Vishesh, please chime in. So what I think the prudent thing to do is we're solving a problem that we don't, that this isn't 20 years in the future. And this is something that's not going to happen overnight. We're hanging our hat on the things that we know, you know, because the things we know, infrastructure is being developed, and we know it will reach, and it has the capability of doing X. And locking that in as, okay, we know that these are the foundational aspects or the pillars of technology that we can count on. And then as we stretch beyond that, we need to be very careful, because if we stretch too far, we don't want the theory or the process to break down and we have nothing. So I think we build foundation like the building on, not saying that we so objective that we lock ourselves in a rigid system that can't be agile and move with technology. But what we're trying to do is set the process in a fundamental structure that will allow the growth of technology to come to the basic terms of the philosophy and the structure of the process that will solve the base problem of absolute minimum variance to whatever it is. I said that earlier, my brain's fried here. But to get a variance of as close to zero as we can get. And so that's my answer to that question. We can't be thinking, let me back up why I'm so, and I think any estimator on the, that has estimating experience on this call or on the team or in internationally speaking, is that estimators, if you give any estimator an analysis, the seasoned ones, because they're the ones that say, yes, corporate executive or whoever, this is a $4 billion project and I know why it is and I agree with it. No matter what the technology says, the estimators that are doing the complex analysis have to at least understand where, what is being utilized in that analysis. And so to have bits and pieces that we don't understand function, or that are missing pieces that we have to stitch in that breaks the analysis, is not conducive to the American Society of Professional Estimators, which we have to understand. We can't, as an estimating profession, we can't put a validity behind something we don't fully understand. And so that's my answer to that, and it may be right or wrong, but and of course this is a profound question that is open to the entire team, of course. But any other comments on that?
Thank you for that. I tend to agree. I think this kind of looks like just basic risk management. That if we can assume low risk for near-term things that we know we can build a graph database of construction costs, even if it doesn't exist now, it's low risk to make that assumption. It's a little bit more of a risk to assume that we can build like an accurate deep learning model that can develop an optimized complex system of systems from a multi-spectral based on cost and everything else. And I'm sure there's a balance there that we'll get into as we get into the nuts and bolts. As you're talking, I think this is another opportunity for potentially a gap analysis, that if we get into this and we find that there are some areas where we need new developments, new technologies that don't exist, things that are high risk, that would be very important to identify so that we can get that out to the world, so that people can start looking for solutions. And even tying that gap into a specific need, a specific requirement, may be important for those program managers to I guess very deliberately put that into their programs if they find that's one of the priority risks.
Yeah, what a great comment. That's a very forward thinking, Steve. Thanks. Brad or Vishesh or anyone else on the team, any comments on that?
No, I think it's spot on. Yeah, I mean, I agree. I think that there's aspects that were already there and that are, low risk to roll out. And then there's the aspects, as Steve said, identifying those gaps and figuring out what we need to do um, to move beyond and collaborate and find, external partners that can develop some of the more complex, harder solutions. So, yeah. I apologize. I've got to run to another meeting, but
Yeah,
thank
and in the interest of time, it's 8 minutes over. Steve, as always, thank you. Everybody on this call, thank you so much. Vishesh and Brad, outstanding work. And I hope you get better. You're amazing. You showed up and helped us administer this meeting, and she's not feeling well today. And we wish you well, and we hope you get rest and enjoy the weekend and do well on your finals or your midterms. So. All right, everybody. I'll see you later. Thank you. This will be posted.
Thank you.
Bye.